on this computer. Awesome. All right, everybody, welcome to week 4. We're already, we're plugging along. So great work, everybody, so far. Oh wait, no, wrong button. Present. There we go. Awesome. Yep. So today we're going to be going a bit more into our data viz. Can everybody see the PowerPoint so far? Awesome. Thank you. Thank you. Thank you. Cool. Yep. So we've done a bit of data viz, but we're really wanting to, really start to like see all that R can do, particularly as we start moving into our C1s. And for those who are new, the C1 is going to be your final data journalism project of your choice. And so I'm going to talk more about that soon, but this lesson in particular, in this week's activities will really help you, get an idea of like all the cool things that you can do. And sometimes it's useful to like start with the data and then think about what you can make, but sometimes it's good to think about, oh, here's what I can make. Let me see what do I actually want to use these tools on. So yeah, our layout for today, we have some announcements coming up. We'll do a very quick review of homework and questions. I'm really going to try to keep that short because I want us to really get the demo in, both for those here and those watching us on YouTube. So if you do have questions about the homework or just the demos or anything that were from like last week, we're more than happy to also answer those later on during breakout rooms or just on Slack. Awesome. So announcements. So yeah, so some of you will notice we apologize for the bug in the demo. I'll send a more like thorough description of what exactly happened. I'm still kind of like making sure, because it still works on my computer, so I'm trying to figure out like how it exactly broke down for y'all. So we'll definitely have that for y'all. Thank you all for finding that. Like that's like, you really know that you're learning this stuff when you catch the errors that we make. So, if you found it, awesome job. And the other thing, so your homework for this week was to kind of start thinking about your C1s. And so now we want to start, accelerating this process. And so just one thing to keep in mind with this is that, this is not supposed to be a stress, like a source of stress. Like obviously these are really tough times with just everything that's going on. So, if it's tough for you to get time in for the C1s, we totally get it. And so what we want to do to kind of help that, and also though, provide resources for those who are, moving along steadily with their C1s, I'm going to send out an Excel sheet. And with that Excel sheet, you'll fill it in when you have an idea of what you want to do. And then we'll sign you up for a quick 10, 15 minutes meetups with either Kevin and I. So we can kind of help you think about, okay, how are we going to get this data? How are we going to start, what's the story that we're looking for? What are the data viz? Where, maybe what are some other skills that we're not going to cover here, but we should teach you so that you can do what you want to do. So, again, we want, the first step to this will be filling out that Excel sheet. Once you fill out the Excel sheet, then we'll send you the request of like, oh, hey, saw you thinking about this. Let's meet up to talk about it. But again, if you haven't gotten the chance to do it, no stress. That's why we're not sending out a form and telling everybody to sign up the form, just because like sometimes when you do that and say like put a due date, everybody's like scrambling, at 11:59 p.m. trying to find something. So we don't want that to be at all a source of stress for everyone. Cool. Any questions about the C1 so far? Awesome. Yeah. Feel free to ask them later if you so wish. All right, cool. Let's do a quick review. Let me go ahead and stop sharing. Share screen. Boom. Bang. All righty. Can everybody see R okay? Can you give me a quick thumbs up? Awesome. Yep. So really this was a very like bulky and maybe not as fun activity. So, massive kudos to you if you're able to make it through. I'm just gonna kind of scroll down to like the very end, because I think from what we understand, most of the people were able to, do these simple ones. I do just want to go to the bottom one to kind of explain, what all these like parsing things were doing. Because really at the end of the day, what was happening here is this is a very heavily data wrangling. So where we had you mutating new columns and then referencing these mutated columns again. So doing what you did and mutating again, and really doing a lot of conversion with all of your exclamation parts, your remainders. And so yeah, I'm not going to go too much in the math, but the real key and what we wanted you to get from here was the idea that it's really, really helpful with very large data sets to make it easier to read, to make it more, I guess, for lack of a better word, colloquial. Like oftentimes we'll have things in like military time, and it's much easier if we have it, in our standard, 1 to 12, 1 to 12 day clock. And then we also had you look at this fun little if-else function down here, which I'll just explain real quickly what this does in case y'all didn't get to it. Basically, if-else you put in a argument. So like if departure delay 2 is greater than negative 90, we want you to put 0 or 140. And so what this is really doing here is it's saying, okay, in my depth delay 2, so in this column, we want it to be the exact same column as it already was with this addition. And what this is really doing is helping you catch up on those weird instances where we're right at like the outliers, right? We're right at like 11:59:12, and it's kind of like it's a little fishy with the time. We can talk more about that later on if you have questions about that. But this was really what we were trying to do here, is catch those outliers where that was messing up our data, and so making it more readable for everyone. Awesome. Any questions on that? Cool. All right, let's go ahead and do the demo. No need to go back to the PowerPoint. I'll just do it here. Cool. So today we're going to be talking about discrete and continuous variables. And we actually had, I forget who it was, but someone had asked this question, way ahead of the curve, and had figured this out a long time ago. Right, but this idea of like, we have some variables which, are very much like numeric, right? Like 1, 2, 3, 4, like very much is a clear level. But then sometimes we have these variables where things are categorical, where we have, let's say, and you can think about this in today, like, you have Republican, Democrat, Independent, you have colors, you have, just things that you're just like, right off the bat, you're not exactly sure. There's not a hierarchy per se. So, it's like, okay, so how do we graph these things? Like, what are the ways that, what are the tools that we have that are best suited to either or? So let's go ahead and take a look at an example of a discrete. So, so this was the cars data set that we have been playing with for a while, which is MPG, which just has a lot of data on cars and models. And so manufacturer is an example of a discrete variable. And I guess it's a little bit tricky to read, but it's like Audi, Chevrolet, Dodge, Ford, Hyundai. And while you might have a personal opinion as to which one's better, right, it's not something that's immediately apparent. And so one very classic example that we use here is GMBar, which gives these nice little bars. And what it's doing here is telling us, okay, how many Audis, how many Chevrolets, how many Dodge, how many Fords are within this data set. Now, and just unless it's a number, it's almost always discrete. You'll actually probably will find more discrete than numeric variables. Simply, particularly when you're like looking at, I guess, like, non like mathy data, like, there's plenty of continuous, but anytime you see a word, you can basically assume that's discrete. The one exception to that will be like, good, greater, best, that, but then again, like, just, we have brains. You'll be able to tell when it's like a continuous versus a discrete variable. Awesome. But now let's, check out what this little chunk does right here. All right. So this, however, is an example of a continuous variable, because this is so this is our diamonds data set we've done a lot of work with. All right, we're going to do more because there's so much to learn about diamonds that you would never even think about. Right, caret, which is this, it's a quantity of measure that you want to be able to use. And so here, it makes a lot more sense to use Histogram versus GMBar. And what you're going to learn is while these, from a visual sense look very similar, you'll actually find a lot of times that when you try to use a GMBar, so like a discrete variable graphing tool on a continuous, you'll get errors, or it'll just look weird. And so you'll begin to like see these different nuances in between them. Any questions so far? Awesome. Let's keep rolling. Yep. So now, so again, so columns that have numerics just generally tend to be continuous. Now let's check out this one. This one's a little bit interesting. So this is back to our cars. So we have CTY versus your cylinder. And so, we kind of see this is a very weird distribution, but they're both numeric, right? And so this is a good little check for us to realize that just because something is numeric doesn't necessarily mean that's continuous. And why is that? For cylinders, they're, while it's, 4, 5, 6, 7, 8, what we can see is, there's no such thing as 7 cylinders. Like, you'll just never find a car with 7 cylinders. So again, while these are numeric, we would qualify this as a discrete variable. And what's nice is, you can immediately tell, like, this is not a very useful graph. Like, this isn't telling me a lot. So this is kind of where you can also, you can see it. You can also look at it when you see the data and you're like, I see a lot of like very specific values that, may not necessarily make sense if we just think about from like, a 1 to 10 scale. So yeah, it's just something to keep in mind. All right, let's go ahead. Yep. Let's go ahead and run this bad boy. So here's another GM histogram of our price. So, this is just real quick. This is showing us, the amount of diamonds within this data set that fall within each price range. And so, I won't read this to you all necessarily here, but, basically the idea here is that, we have price, and technically, price, like if you want continuous, the idea of continuous being that there's like something at every single point. Obviously with price, we can't go to like lower than a penny. So while technically this, some people, you could argue like by the definition, it's discrete. We clearly obviously treat it as continuous, and it looks pretty clear. Awesome. So here are 3 major tools that you're going to be using a lot and you see a lot, which is GMHistogram, which is something that we've been seeing here, GMBar, which is something that looks like this, and then GMCall, which is going to look very similar to GMBar, but there's a slight difference, and this is what I was pointing to. GMHistogram we use for 1D continuous plots. So when you want to count how many things you have. So right, you have a data set. I want to see how many price. I want to see how many I have that cost, I guess this is like it's around $100. Then I want to see how many cost like $15,000. GMBar is used for 1D discrete plots when you still want to count, but it's instead of continuous, it's discrete, right? We have Audi, Chevrolet, things that are not necessarily in a hierarchical order. And then GMCalls are a little different one. It's for 2D discrete continuous plots. So wrestle with that. We're going to quickly go through the other examples, but I'll show you what this is in a hot second. This is kind of the one where it gets a little confusing. So yep. So here again, just classic caret, continuous. Very easy. We could have probably done better with the bin width. Yep. And then, oh yeah, look at that. We do pick a better bin width right there. Yep. And a quick clarification what the bin width is. I think we had mentioned this before, but just in case. So here, the bin width is how wide each one of these little groupings are. So here its bin width is 30. So it's basically finding, this is like probably 3 to 0.6. And we're like, well, we actually want it by 0.1, which you can see gives you a lot more information about what's actually going on. So that's a very powerful thing with GMHistogram. Then here's our GMBar that we had. Bam. Yep, exactly the same thing we had above. And then, yep, manufacturer's discrete. Again, here, this is actually, with our cylinders, even though this is numeric, there's only certain values. So we want to go ahead and treat it with the GMBar as if it's a discrete one. And then let's go ahead. Now here is our GMCall. So what in the world is going on here? So let's check it out. So we have X is our destination, while Y is our airtime. And so we have X, airtime here, and we have GMCall. So what's happening? Here, these are very obviously discrete variables, right? It's, ORD, IAH, AID, Dallas-Fort Worth, Atlanta. But then the airtime is continuous. So then in order to compare these two, discrete to continuous, that's when you want to break out that GMCall. And that's going to be really, really useful. I'm actually, for the sake of, I don't know, we got a little bit of time, but you can also look in, I'll go through this a little bit quickly because most of what we've been doing so far is continuous. And this is where you want to break out like GM point, which we've been using a lot so far. So continuous is going to be right, caret and price, 2 things. Yep, so you want, right, this is a lot better to see exactly where everything is. Because, with continuous, typically also with continuous, there's a lot more data because you're within all these little categories. Whereas, right, with discrete, usually it's only like probably less than 10 within each variable. Yep. One thing we want to talk about, I think a couple people have figured this out. But whenever you have GM points, one thing we highly recommend adding is GMSmooth. And what GMSmooth does, it basically just takes the average and puts a line. So, if you've taken stats and like you've learned about like linear regression, great. Quick crash course stats 101. What that basically is doing is it's finding the average of where everything is, like the overall average trend. This is, GMSmooth will give you that. So you can kind of see, particularly when you have like a lot of data, it's like not super clear where everything is here. This line is super helpful in helping you find that out. And this little gray thing up here is basically just saying we don't have a lot of data. So really this could, maybe this line could go here, maybe it could go here. We're not really sure, but we're kind of just like eyeballing it. Any questions so far? We're almost at the end. Awesome. Cool. Another really cool one with continuous is GMHex. This one, I think a couple students found. This one's really fun. This one is counting the amount of each one. So it's the exact same thing as this graph, but here, right, it's kind of hard to tell how many dots are in each place. Here, it tells you it exactly. So we have this nice little legend here that says, okay, count, 5,000. So right here, I have a ton right here. Whereas then you can kind of see this little trend line that we see up here. And the rest of this is about the same. So this is a very powerful tool. It looks cool as well. Yep. And then here's some just have some fun here. Here, these are some really, so what is scale x log 10? Kind of looks a little scary, but bear with me. We think that's like relatively self-explanatory. It's scale x, so our x-axis, log 10. So we're basically doing this in terms of logs. And we do in terms of y of logs as well, which can be really useful because we can kind of see like, it gets a little crowded here. The log 10 really helps to separate things. And then scale fill for area C just makes it a different color, which is a lot. I mean, I like this color a lot more just because it's a bit, pops a bit more. And you can do all different types of colors. Like there's, just Google GMHex colors, like scale of Adirius, and you can do like red to orange, light colors, dark colors, gray to black, if you want to do it that way. So again, like this gives us a lot more, whereas here it's like kind of still like a little messy. This now lets us really see where those little pinpoints are, which is really, really cool. All right, some final additional specs I'll just run through. Yep, GMSmooth. Same thing we talked about with that little line. Yeah, the little argument SE false removes the trend line, which is that gray thing. You can do that. You don't have to, up to you. Here's one thing that's super cool is you're like, whoa, what in the world happened here? So here we added this argument color equals DRV. So this is another variable, a discrete variable for FR. And we said, well, we want you to actually color these points as well. And so you can, and it applies to everything. So now we can actually see what is what, which is super cool. And this gives you a lot to work with. So I highly recommend if you have G on point, breaking out this third variable, because this allows you to see three things. Instead of just highway and displacement, you can also see the drive. Yep. And, I'll just run these so you can see them. For the sake of time, I'm not going to say exactly what they are. Feel free to go to this. It's a shape. The points are different shapes. Here we have line type, which, guess what that is? Different lines. And then we can also, here's some pretty labels, which I will let you all, you're going to have to do some very interesting labels this time. So I'm going to let you all fill you with these. I'm not going to give away too much about this. Oh, Eleanor, yes. Feel free to unmute yourself.
Can you just go over what the DRV4FR is again? Like
yes. This one right here?
Yeah.
Yep, awesome. So DRV, let's use our handy dandy little help function here. Let's see what MG. Awesome. So yep, again, I'll just put it in our help because I don't. It's certainly hard to remember sometimes. Awesome. The type of drivetrain where F equals front wheel drive, R equals rear wheel drive, 4 equals 4-wheel drive. And you can see why this would then be like useful because we're like, okay, so we have highway, which, yeah, let's look it up here real quick. Highway is going to be our, where'd it go? Yeah, highway miles per gallon. And then displacement is engine displacement in liters. So, it's the idea being, what is an efficient car with both speed and how much fuel you're using. And drive then actually lets us see, okay, what exactly are the cars that do best at this? So, you can kind of see, 4-wheel drive is probably like are fairly standard because it goes across, there's like a ton of different cars with 4-wheel drive. But, maybe it might not give you the most optimum output. Whereas green, this gets you that fast speed, but you're not getting a great bang for your buck in terms of displacement. And then blue's the reverse. So you're getting a very good bang for your buck for displacement, but, you sacrifice a bit of speed. And I bet 4-wheel drive is pretty standard. I bet the blue cars are a bit more expensive. So I don't think they have price, unfortunately, as a variable, but that'd be pretty fun to compare as well. Yeah, that makes sense?
Yeah, thank you.
Awesome. Cool. I think that's it for now. So thanks for those watching us online for tuning in, and we'll see y'all soon.